This video will discuss Georgia Standards of Excellence 2OA2, which states that students will fluently add and subtract within 20 using mental strategies. By the end of second grade, know from memory all sums of two one-digit numbers. Students begin working on their fluency in kindergarten when they focus on adding and subtracting within 5. In first grade, the emphasis is on being fluent within 10. In second grade, students continue developing first grade strategies to become fluent within 20. Second graders then use those strategies as they work on adding and subtracting larger numbers. By the end of the year, second grade students should know from memory the sums of all two one-digit numbers. As students progress to the upper grades, they begin to focus on fluency with multiplication and larger numbers. To learn more about the specific strategies that students should use when developing fluency within 20, please watch the first grade video on 1OA6, which shares additional guidance on strategies such as counting on, making 10, using the relationship between addition and subtraction, decomposing a number leading to a 10, and creating equivalent but easier or known sums. Although students implement these strategies when dealing with addition and subtraction within 20, the goal for first grade students is they develop fluency within 10. In second grade, students will develop their fluency within 20 throughout the year while reviewing and implementing strategies that were introduced in first grade. In the subsequent slides, a few strategies will be demonstrated. One strategy that students can use is the make a 10 strategy. When adding 9 plus 6, students can think about how many more should be added to 9 to make 10. 9 plus 1 equals 10. The 6 is decomposed into 1 and 5. We now have 10 plus 5, which equals 15, which means that 9 plus 6 also equals 15. When adding numbers such as 8 plus 9, students may also want to use doubles facts, or facts that they know, to make adding and subtracting easier. If students know that 8 plus 8 equals 16, 9 is only one more than 8. So, 8 plus 8 plus 1 more is the same as 16 plus 1 equals 17. Therefore, 8 plus 9 equals 17. The make a 10 strategy can also be used with subtraction. Students can think about the teen number. 13 is made of 10 and 3 ones. We can decompose the 5 so that we can take away 3 and then 2 more. When we take away the additional 2, we have 10 take away 2, which equals 8. So as we dive into the standard, it is important to address what fluency means. The practice of using time tests and speed drills in the attempt to help students achieve fluency only provides a one-dimensional view of what mathematical fluency really is. Fluency does not mean speed and time test. The National Council of Teachers of Mathematics describes procedural fluency as the ability to apply procedures accurately, efficiently, and flexibly, to transfer procedures to different problems and contexts, to build or modify procedures from other procedures, and to recognize when one strategy or procedure is more appropriate to use than another. Flexibility plus efficiency plus accuracy develops fluency. As shown by these models, flexible thinkers can solve problems in a variety of ways. For example, when solving 9 plus 4, the 9 can be decomposed into 6 and 3. 6 and 4 make 10. 10 plus 3 equals 13. As shown with the number line and 10 frames, the 4 can be decomposed into 1 and 3 to make 10. In addition, when solving 8 plus 6, the 6 can be decomposed into 2 and 4 to make 10. Students may also think of double facts and see 6 plus 6 plus 2 to visualize that 8 plus 6 equals 14. In the next few slides, you will see the fluency strategies in action. After sorting a set of cards into different categories, students then explain why their strategy would work. As students worked collaboratively, they discussed the reasonableness of their answer and modified their thinking as needed.
Why did you put 12 minus 3 under make a 10?
I can just count back 2 and then 1 more equals 9.
Why did you put 13 minus 9 under think addition?
Because I can find the difference by counting up.
Students can apply the Fluency strategies with puzzles such as magic squares. As students work out the puzzles to solve for each specific sum, they must use all the digits 1 through 9. The known sum in this puzzle is 15. As the student solves the puzzle, she implements a variety of strategies to find the missing add-ins.
You already have 4 and 5 going diagonally. What could the missing number be to make 15?
Six.
Yes.
When making a 10, students know that 9 plus 1 equals 10. So 5 more is needed to make 15. If students add 2 plus 6 together to get 8, they can think of their doubles facts. 8 plus 8 equals 16. The missing add-in must be 7, or 1 less than 8 to get 15. A fun game to reinforce the double strategy is dominating doubles. Students will roll a 10-sided die and then double that number. The goal of the game is to cover 4 in a row. Therefore, the student may decide to only double the number, use doubles plus 1, doubles minus 1, doubles plus 2, or doubles minus 2 to find the number that best meets his or her needs. Students can use models such as Reckon Recs or 10 frames as manipulatives to help determine the best strategy, which could even be to block your opponent from getting 4 in a row.
So what did you roll?
6.
6. What is 6 plus 6?
12.
12. Okay, so what strategy are you going to use? Doubles minus 2. So what is 12 take away 2?
2.
Okay, now you have 3 in a row. You rolled a 6. What is 6 plus 6?
12.
12. Okay. What is 12 plus 1?
13.
What should you cover on your board?
13.
As students apply strategies throughout the year, they become flexible and efficient thinkers. In this game, one student looks at both cards and finds the sum, while the other students try to figure out the missing add-in.
So what's the sum of their numbers?
11.
Okay, so what number is on your head? If the sum is 11,
4.
you have a 4, because 4 plus 7 is 11.
As students build fluency, they can be introduced to more rigorous tasks. In this activity, students demonstrate their true number sense as they use Cuisenaire rods to add within 20.
I know.
So how did you solve 7 plus 9?
I changed it to 9 plus 7, and what I did is I have 9 cubes, and then I added 1 more from 7 to make that a 10, and then so I have a 10, and then if I took 1 away from 7, that equals 6, and then and then I know that 10 plus 6 equals 16.
Can you add 11 plus 4 using the rods?
Yes. 10 plus 1 equals 11, and 4 more makes 15. So 10 plus 5 is the same as 11 plus 4.
For additional tasks and resources, please visit Unit 2 in the 2nd grade Georgia Frameworks. There are a variety of tasks as well as remediation and enrichment activities available. You can also review Unit 3 in 1st grade for additional resources on developing fluency within 20.